Good day. So in this lesson, we are going to look at binomial expansion and as well as expanding using the Pascal's triangle. So yeah, let's go ahead and look at what the Pascal's triangle is, and also let's look at what the binomial theorem is. Now, let's look at the Pascal's triangle first. What is the Pascal's triangle? So the Pascal's triangle, it gives you the coefficients of the terms in the expansion. So let's suppose you want to expand an expression a plus b to the power of n. So let's say n is 4, or a can be any variable in terms of x, and also b can be any variable in terms of x. So to get the coefficients of the terms in the expansion, this can be determined using the Pascal's triangle. So the Pascal's triangle starts with two coefficients, 1 and 1, and you can now add 1 and 1 and you get a 2, and you rewrite again 1 and another 1, and again you go ahead and write again 1 here, then you add 1 and a 2, then you get a 3 and a 2 and a 1, you get a 3 and a 1. Then you can continue again with the pattern, 1, then you add 1, 3, then you get a 4, then you add a 3 and a 3, you get a 6, then you add a 3 and a 1, then you get a 4 and also another 1. Then you can go on to the fifth row. In this case, that will be 1, 5, 10, 10, and another 5 and a 1. So what you see here, these are the coefficients in the expansion. So let's suppose you were asked to expand a plus b to the power 5. So the coefficients of that expansion will be in the row 5. So in the row 5, that will be 1, 5, 10, 10, 5, 1. So you would write first off all your coefficients. So 1, then you write your 5, then your 10, then another 10, a 5, and a 1. So let me just write 1 here. So this is how you expand this expression. So the a, which is here at the beginning, its powers go in descending order. So you start with a to the power 5, going to a to the power 4 until you reach a to the power 0. So you start writing them from left to right. So in this case, that will be in here. Let me just change the color. So that will be a to the power 5 on the coefficient of 1, then a to the power 4 on the 5, then a to the power 3, then here a to the power 2, and a to the power 1, and lastly a to the power 0. So that's what happens with this a term. Now for b, the powers of b will decrease, will be in descending order from right to left. So you start again here. Let's use a different color. So that will be now b to the power 4, because b to the power 5, because the highest power is 5. So that is b to the power 5. So here that will be b to the power 4, b to the power 3, b to the power 2, b to the power 1, and lastly b to the power 0. So one thing that you need to realize here is that all these powers, so you've got 5 and a 0, they should always add to this 5. So 4 and a 1, they add to 5. 3 and a 2, they add to 5. 2 and a 3 add 5. So they should always add to 5. Then you can go ahead and simplify this thing further. Then you will have 1 a to the power 5. Then b to the power 0 is just a 1. Then plus 5 a to the power 4b. Then that will be plus 10 a cubed b squared. Then plus 10 a squared b cubed. Then plus 5ab to the power 4. Then plus, there's no need to write a 1. So that will be just b to the power 5, because a to the power 0 will give you a 1. So this is how you expand using the Pascal's triangle. So even if you had a negative here, so you would have inserted the b always with a negative. So you'd say negative b either to the power 4 or whatever power. So this is how you use this Pascal's triangle. So if you had been asked again, a plus b to the power 4, then you would use the row number 4. Now let's look at the binomial theorem. Now let's suppose you still had that expression a plus b to the power of n. So now we're using the binomial theorem. So the binomial theorem uses the combinations. So there is a formula for combinations that you need to know. This formula is n choose r, then that will be a to the power n minus r. So whatever you have chosen for r here, so you can have a range of choices from 0 to n. So if let's suppose that was a plus again b, let's say to the power 5. So n here will automatically be 5. But what you're going to choose as r can range from 0 to 5. So you have to choose from 0 until 5. Remember, you choose from 0, not from 1. Because any number choose 0. So n choose 0. Any number choose 0 will always be equal to a 1. So remember that you choose from 0. So this expression, it's on your calculator. So you just say n choose r, then a to the power n minus r. So you minus the n, the r from n. So that will be a. This a will be a to the power n minus r, then b to the power r. So it is as simple as that. So let's go ahead and look at an example whereby we're going to expand this a plus 5, a plus b to the power 5. Now, to do this expansion, we first of all choose 1. So we have options to choose from 0 to 5, remember. So now that will be the first term will be 5, choose 0. Then a is the first letter here or term. So that will be a to the power n minus r. So that will be 5. Then a b to the power r, in this case it's a 0. That is the first term. So then the second term will be 5, choose 1. Then now a to the power 5 minus 1, which will give you a 4. Then b to the power r, which will be 1. So that is term number 2. So let's say this term 1, then term 2 equals, then term 3 will be equal to, in this case, that will be 5, choose 2. A to the power 3, then b again to the power 2. That will be term number 3. Then term number 4 will be equal to 5, choose 3. A to the power 2, 5 minus 3, that will be a 2. Then a b to the power 3. Then term number 5 will be equal to 5, choose 4. Then that will be a to the power 1. 5 minus 4 is a 1. Then b to the power of 4. Then the last term, which is term 6, will be equal to 5, choose 5. Then a to the power 0, because 5 minus 5 is a 0. So a to the power 0. Then b to the power 5. Then you can go ahead and punch this in your calculator. Like for 5, choose 0, you punch in 5. Then you'll see that there's a button on the second function saying NCR. Then you say shift, second function, you press that NCR. Then you put a 0. So you realize that 5 choose 0 will be equal to a 1. So 5 choose 0, it's a 1. So that will be 1 times a to the power 5 and b to the power. So that will just be a to the power a 5. Then you go ahead and do 5 choose 1. 5 choose 1, it's a 5. So that will be 5 a to the power 4, then a b. Then you go to choose 5 choose 2. Then you realize that 5 choose 2, it's a 10. So that will be 10 a cubed b squared. Then 5 choose 3 will also give you a 10. So that will be 10 a squared b cubed. Then 5 choose 4 will give you a 5. So that will be 5 a b to the power 4. Then 5 choose 5, that will give you a 1. Then a to the power 0, it's a 1. Then here it's b to the power 5. So then you just go ahead and write down the terms. So that will be now the first one here, a to the power 5 plus 5 a to the power 4 b plus 10 a cubed b squared, then plus 10 a squared b cubed plus 5 a b to the power 4, then plus b to the power 5. So you realize this is the same answer that we got when we expanded using the Pascal's triangle. So I like this binomial method because now it helps you to get, like, sometimes they ask you find the term maybe when it's a plus 10 to the power of 20. So you don't want to use a Pascal's triangle when it's power 20. Maybe they ask you what is the third term. So you know that the third term in this case will just be 20, choose a 2. Remember, first term start on 0, 1, 2. Then you just find that term. But using the Pascal's triangle, yeah, that is going to take a long time. So yeah, with that in mind, let's look at some examples. Now, in this example, we are asked to use the Pascal's triangle to expand 2 plus 5x to the power 4. Now, to do that, remember what we need. We need first our coefficients. So remember the coefficients. To do the coefficients, we start off with 1, 1. So we go here 2, 1, 1, 3, 3, 1, 1. This is a 4, 6, 4, 1, and a 1. So now we want the row 4. So in this case, our coefficients are 1, 4, 6, 4, and a 1. So we have got 5 terms. So remember what we said for the 2, it will be written now from left to right in descending powers of that 4. So in this case, we start with 2 to the power 4, then here 2 to the power 3, then 2 to the power 2, then 2 to the power 1, and lastly 2 to the power 0. Then for the values of 5x, they will start from here, from right to left. Remember, from right to left. So we start with the highest power, power 4. Then we go on 5x to the power. So that will be 5x to the power 3. Then we go on 5x here to the power 2. Then here 5x to the power 1. And lastly, that will be 5x to the power 0. So yeah, you just go ahead and also put your plus in between because these are terms, so they are adding each other. So then the final answer will be, in this case, that will be 2 to the power 4. That will be 16 plus, here that will be 4 times 8 times 5. That will give you 160x. Remember, there is x, 5x to the power 1. Then plus here, that will be 6 times 4 times a 5 times 5 squared. And this will give you 600x squared. Then plus 4 times 2 times 125, that will give you a 1000x cubed. Then plus, that will give you 5 to the power 4. In this case, that will be 625, because 2 to the power 0 will just be a 1. So that will be 625x to the power 4. So this is the expansion of 2 plus 5x to the power 4 using the Pascal's triangle. I hope that makes sense. Let's have a look at the second example. Once again, in this example, we are asked to use the Pascal's triangle to expand 1 minus 2x to the power 4. So if you remember very well, our coefficients for the row 4 were 1, 4, 6, 4, and a 1. And in this case, now we have got a 1. So we write 1 in descending powers. But there's no need to write 1 because any number that is going to be raised 1 to will always be 1. Even 1 to the power 20, that will always be 1. So in this case, we just concentrate on the negative 2x. So it is important that you take note of the sign. So we write from, remember now, this one, it's from the right to left. So we write negative 2x to the power 4. That is the highest power. Then here negative 2x, then to the power 3. Then here negative 2x to the power 2. Then negative 2x to the power 1. And again, negative 2x to the power of 0. Then you just go ahead and put your plus signs in between because these terms will be plusing each other. And then you go ahead and simplify that. So this will be just 1. So this negative 2x to the power 0 is just 1. So that will be 1. So this one will be negative 2 times 4. That will be negative 8x. Then here it will be 2, negative 2 squared. That is a 4. Times 6, that will be 24x squared. Then here it will be negative 2 cubed, that is negative 8. Then times a 4, that will give you negative 32x cubed. Then this one will give you automatically a plus. So that will be here negative 2 to the power 4. That will be 16x to the power 4. So one thing that you have to note here, there will be always signs alternating, a negative, plus, negative, plus. They don't go like negative, negative, plus, plus. So they have to alternate if you have got a negative there. And ladies and gentlemen, this is how you expand 1 minus 2x to the power 4 using Pascal's triangle. Now let's look at the next example. Now, in this example, we are asked to find the coefficient of the term in x to the power 6 in the expansion of 2 plus 3x to the power 9. Now, we have got a power 9. So, if you are going to use Pascal's triangle, it's going to take forever because you have to get the coefficients in the row 9. And this will take a long time. So, this is the moment where you have to use that binomial theorem. So, if you remember very well, we said in the beginning, if you have got an expression a plus b to the power of n, so the expansions or the terms in the expansion of this expression can be given as n choose r, a to the power of n minus r. So n minus r, then b to the power of r. So in this case, we are asked to find the term in x to the power 6 of this expression. So if you look at this, this is like your a, it's a 2, then plus 3x, your b, it's 3x, then to the power, your n here, it's a 9. So that is actually a big number to use the Pascal's triangle. So we want actually the term that has got x to the power 6. So that is the b term. You can see that the x is only on the b. So we want to raise this to be power 6 so that we get what the coefficient is of that term which has got power 6. So you can see now, in order for us to have a power 6 on the b, we need to raise r. So our value of r should be equal to 6. So we need to choose 6. So in this case, we do not, for n is fixed. So that will be, now in this case, that will be, n is 9. So that will be 9. 9, choose 6. Then our a is 2. So that will be 2 to the power 9 minus 6. And 9 minus 6, it's a 3. Then multiply by our b, it's just 3x, then to the power of 6. So if we go ahead and simplify that, we realize that 9 choose 6 will be 84. Then times 2 to the power 3, that will be an 8. Then times 3 to the power 6, that will give us 729 x to the power 6. And if we multiply 84 times 8 times 729, that will give us 489,888 x to the power 6. So the coefficient of the term in x to the power 6 will be 489,888. And that is how you find the coefficient of the term in x to the power 6. I hope that makes sense. Let's look at the second example. Now, in this example, we are asked to find in ascending powers of x the first three terms of 1 minus x times 2 plus 3x to the power 9. So yeah, the only thing that you need to concern yourself with using the binomial expansion, it will be 2 plus 3x to the power 9. Then after you get those first three terms, when you use the binomial expansion, then you can multiply with 1 minus x. So yeah, let's go ahead and find the first three terms. And remember what we said. So term number 1 will be equal to 9. So it is 9 is fixed. That is our n. So 9 choose 0. Remember that is the first term is always choose 0. Then our a in this case, that will be 2 to the power 9 minus 0. That will be 9. Then multiply by a 3x to the power of a 0. That will be term number 1. And this will give us 512 because 2 to the power 9 will give us 512. Then we go ahead and do term number 2. That will be 9, choose 1, and 2 here again to the power 8, which is in this case 9 minus 1. That will give us an 8. Then multiply by 3x, in this case now to the power 1. And this will give us 6,912x. Then we go ahead and look for the term number 3, which will be in this case 9, choose 2, then 2 to the power of 7, multiply by 3x to the power 2. and this will give us 41,472x squared. Now we have got the first three terms. So we just multiply these first three terms with the 1 minus x bracket. So we just go ahead and say 1 minus x bracket, then multiply by 512, the first term, plus 6,912x, then plus 41,472x squared. So then if you expand that, you will get, when you simplify, you'll get 512 plus 6,400x, then plus 34,560x squared, then minus 41,472. So yeah, these are the first four terms, but you just need the first three terms of the expansion. So that will be 512, 6,400, then and 34,560 x squared. And this is how you do the ascending powers of x for the first three terms of 1 minus x bracket 2 plus 3x to the power 9. Now let's look at the another example. Now, in this example, we are asked to find the first 5 terms in the expansion of 2 plus x to the power 6 in ascending powers of x. So yeah, let's go ahead and use our binomial theorem. So remember, term number 1, in this case, we say 6, choose 0. Then 2 to the power of 6, then multiply by x, in this case, to the power of 0. Then term number 2 will be equal to 6, choose 1, then 2 to the power 5, then x to the power of 1. And also term number 3 will be equal to 6, choose, in this case now we choose 2, then 2 to the power 4, then x to the power of a 2. Then term number 3 will be equal to 6, choose 3, then that will be 2 to the power of 3, then x to the power of a 3. Then term number 4 will be equal to 6, choose 4, then that will be 2 now to the power of 2, then x to the power of a 4. Then term number 5. So this term number 1, 2, 3, actually this is number 4, and this is number 5. So when you simplify this, this will give you 64, and this will give you 192x, and this will give you 240x squared, and this will give you 160x cubed, and this will give you 60x to the power 4. So now we have got the first 5 terms, which in this case will be 64 plus 192x, then plus 240 x squared, then plus 160 x cubed, then plus 60 x to the power 4. So these are the first 5 terms of the expansion. Now that we have our expansion, we are asked to use our expansion to show that 2.03 to the power 6 is equal to 69.9804 to 4 decimal places. So yeah, how are we going to do that? So first thing that we need to do, we need to compare this 2.03 and we need to write it in the form of, in this case, that will be 2 plus x to the power 6. So to break down this, we need a 2 at the beginning. So that will be here 2 plus, then 0.03. So the x value will be 0.03 and the 2 is the constant. It is the same to the power 6. So that will be equal to, in this case, 2 plus x to the power 6. Now we go ahead now. So now we know that our x value is 0.03. So we go ahead and substitute that x value into that expansion. So that will become 64, then plus 192 bracket 0.03, then plus 240 bracket 0.03 squared, then plus 160 bracket 0.03 cubed, then lastly plus 60 bracket 0.03 to the power of 4. And when you put this whole thing into the calculator, then you get 69.9804 0.04 to 4 decimal places. And this is how you show that 2.03 to the power 6 is equal to 69.9804. Now let's look at the next example. Now, in this example, we are told that 2 minus ax to the power 8 is equal to 2 to the power b minus 5,120x plus 6x squared plus and so on. And we are asked to find the value of a, b, and a c. So what we are actually given, these are the first three terms. If you look at it, this is the first three terms of this expansion. So what we want to determine first are the first three terms using the binomial theorem. Then we just equate them. So let's go ahead and look for the first three terms. So remember, the first term, it's always 8, choose 0. So it's 8 here. Then in this case, that will be a 2 to the power 8 minus 0. That will be 8. Then in a bracket, negative ax. Remember your negative. Don't forget your negative. Negative ax here to the power of 0. And that will give you 256. Then the second term, so this term number 1. So the second term will be equal to 8, choose 1. Then it will be 2 to the power 8 minus 1. That will be a 7. Then in a bracket, negative ax to the power 1. And that will give you negative 1024ax. Then for the term number 3, that will be 8, choose 2. 2 to the power of 8 minus 2. That will be a 6. Then in a bracket, negative ax to the power of a 2. And that will give us 1792 a squared x squared. So we just need the first three terms because that's what we are given. So this term 1, 2, and 3. So we've got the first three terms. So then we go ahead and equate these things. So we'll say now 256 will be equal to 2 to the power b because that is the first term. And we can actually say here now 256, that will be 2 to the power of 8 is equal to 2 to the power of b. And our b will be equal to 8. And we go ahead and do the same thing for the second term. So negative 1024 ax will be equals to negative 5120x. So then the x will just cancel out. And we can divide by, in this case, negative 5120, then divide by negative 1024, and that will give us the value of a is equal to 5. Now we've got the value of a. So we go ahead again and do the same thing for the third term. So for the third term, so cx squared will be equal to 1792 a squared x squared. So again, the x squared, they cancel. And we are left with c is equal to 1792 a squared. But if you remember very well, we calculated the value of a, and the value of a was 5. So we go ahead and say c is equal to 1792, then bracket 5 squared, and then we get the value of c is equal to 44,800. So this is how you determine the value of c. Now let's move forward to the last example. Now, in the last example, we are asked to find the term that is independent of x in the expansion of x squared minus 1 over x to the power 9. So yeah, to do that, we need our binomial theorem. And remember the binomial theorem, we say that that is n choose r, a to the power of n minus r, then b to the power of r. So yeah, what we have here, we have got our a as x squared. So that is x squared. So we need to find what is that number that we need to choose. So 9 choose what? And x squared to the power what? And also here our b value is negative 1 over x. So what we need to choose a value such that the power of this x squared here will be the same as this power at the bottom so that they can cancel each other. And ultimately then we won't have the x squared. Then we just have the coefficient. So what you can do, you can go ahead and do a trial and error. You can start by saying choose 1. Then you know this will be power 8. If you choose 1, that will be power 8 here. and also here power 1. So you can see that that will become x to the power 16, and this is power, it's x to the power 1. So they won't cancel here. So if we jump and just look at power 2 again, you see that will be power 8 here. That will be 9 minus 2, that will be a 7. So that will be power 14. So if we just look at here, we have to select a power 3. So we have to say 9, choose 3. Then that will become x squared to the power of here, that will be power 6. Then here bracket negative 1 over x, then again to the power 3. And you see this is power 12 and this is a power 3. So again, they do not cancel. So let's go ahead and choose a number. So in this case, what we need is actually to choose 5. So if we go a 9, choose 5, then we realize that this becomes x squared to the power 9 minus 5. That will be a 4. Then we'll be have 1 over x, then to the power 5. You see this is power 8 and power 5. So again, they don't cancel. So let's go ahead and choose a 6. 9, choose 6. That becomes x squared, then to the power of 3. Then here we have negative 1 over x to the power 6. Now we have got our number. Because now we have got here, that will become x to the power 6. So it will be 9, choose 6, x to the power 6, multiplied by negative 1 over x to the power 6. And you can see now that these x to the power 6's will cancel. And then you realize that your coefficient will be 9, choose 6, and that will be 84. So the coefficient of that term, or the term that is independent of x, is 84. And this is how you determine that. And this marks the end of our lesson. And I hope to see you in the next lesson. Bye for now.